Hi students, welcome to this session on physical meaning and the important aspects of wave equations. Everyone knows that these two are wave equations in terms of electric field and magnetic field in free space. Let us see what are the information we can gather from these two equations. The first thing is we know that E is a function of what do you call, it's a vector. So we can write V is equal to Ex, right? X component plus Ey y vector plus Ez is a z vector, right? So here you see E is a function of x, y, z. That means E varies along x-axis because x unit vector gives direction. So E varies along x-axis, y-axis, and z-axis. Fine. So it is a function of three coordinates, right? X, Y, Z. So E is a function of Cartesian coordinate system. So E is a function of X, Y, Z in Cartesian coordinate. Fine. So that is the first thing we have to know. Okay. So and you see in right hand side, E is a function of time. E varies with respect to time. Dou squared E by dou t squared. So this indicates E varies with respect to time. That is, E is a function of time. So E is a function of this is space x, y, z. E is a function of time. So E is a function of space and time. Fine. So anything which is a function of space and time is known as wave. So electric field, this is a wave equation. So similarly, the same logic applied for H also. So these two equations are wave equation. This implies 1 and 2 are wave equation. First one is for wave equation for electric field, wave equation for free space in electric field. Second one is wave equations for free space in magnetic field, everything in terms of H. Here, first equation, everything in terms of E. So that is the first thing we have to remember, right? So second point we have to, what we have to notice, here you see E is a function of three component. E is having three component, Ex, Ey, and Ez. Yes or no? So what will happen to del squared E? That is the left hand side. So del squared E will become dou squared E by dou x squared plus dou squared E by dou y squared plus dou squared E by dou z squared. Fine. So but we know E has xyz. Here it is having xyz component. Here also E is having xyz component. Here also E is having xyz component. So what will happen here is, right, my E will be having, we know it is having a xyz component, Ex, Ey, and Ez, right? So if I put Ex, what I will get? Dou Ex by dou x, then dou Ex by dou y. Here also 1x, here also 1x, here also 1x. Dou Ex by dou z. Similarly, here we have dou Ey by dou x. Here also 1y, so dou Ey by dou y. Here also 1y, dou Ey by dou z. Similarly, we have a z component. So what happens? Dou Ez by dou x, dou Ez by dou y, dou Ez by dou z. So how many components are here we have? So here we have totally 9 equations. So del squared E, that is the left hand side, is equal to 9 equations. Yes or no? In the left hand side, these equations are hidden here. So it is very difficult to evaluate at the same time. Very difficult to evaluate. So these equations are complex, right? Because 9 equations are there, so it is very difficult to evaluate. So what we are going to do is, and moreover, this is a vector equation. So for mathematical simplicity, we are going for scalar equation. How we are going to write? We have to make with some assumption. What is the assumption we are making? We make the first assumption is let wave propagates in x direction only. Wave propagates in x direction only. That is the first assumption we make. Second assumption is let E has only EY component. Right? So what will happen to our equation? So then our equation will become, you see left hand side, okay, let me write again, wave equation. The same thing we have to apply for H also. The left hand side we have del squared E, right hand side mu E dou squared E by dou T squared. So now the assumption is the wave has only X component in X direction and it has Y component only. So out of 9 equation, we take only one component. What is that? So it is dou squared E, it has Y component and it varies in the X direction, right? So this is direction, this is component. That is equal to mu epsilon dou squared EY by dou T square. Fine. So it is a second order differential equation. It is easy to evaluate. Yes or no? That's why we are writing like this. Okay. So here you see x propagates in x direction. Okay, let me go there. You see why it has come this? It has come like this. You see left hand side is del squared E. If you write del squared E, it has 9 part because del squared E is 3. For each equation, we have 3 sub equations. So totally 3 plus 3 plus 3, 9. Now we take, it is propagating in y direction and propagating in x direction and it has only y component. Fine, this is what we have taken. So instead of 9, we have taken only one component, that is a scalar, because Ey is a component of the vector. Yes or no? So Ey, you see Ey is a component of vector which is a scalar. Fine. So the vector equation becomes scalar equation and it is easy to work, and ultimately the wave equation becomes a differential equation. It is a scalar. So it's a scalar equation. It is easy to work with. Fine. Okay. Now we come to the third point. What is the third point we have to remember is we assume that wave propagates in x direction and has y component. So wave propagation in x direction means what? Right? So it is let me draw the diagram, then you will understand something. So here, what is the thing? The wave is let us think, right? So here you see the wave is assumed to be propagating in x direction. So this is x. Let us assume this is y. This is z direction, right? So the wave propagates in x direction. Fine. So electric field will be in y. It has only y component. Y means this one. So electric field will be like this. Fine. So electric field will have a y component. This is what my electric field. Electric field is along y component. If electric field is along y component, magnetic field should be in z component. So okay, I use some other color. So magnetic field will be in magnetic field will be in z component, z direction, right? So Ey. This is H. Here you see, if the wave propagates like this, it appears that YZ plane is, this is like a plane, it is coming front, it's coming in this direction. It is coming in X direction. That is, this plane is assumed to be coming or propagating or moving as a wave front. You see, this is the way it is moving. XY plane is assumed to be it's acting like, it's appearing like moving, right? So that's why it is called uniform plane wave. Right? When you have a assumption like this, that is a wave propagates in x direction and E has only y component, it appears that this YZ plane is moving as a wave front, like moving as a wave. It is propagating along x-axis. So it is appearing like this plane. So that's why it is called plane wave. Okay, so that is the thing we have to remember. Why it is called plane wave, right? So what is plane wave? So yeah, uniform plane wave, right? Let us define that. Yeah, an EM wave, an electromagnetic wave propagating, right, in x direction, right, is said to be uniform plane wave if its E and H electric field and magnetic field are independent of Y and Z directions, right? So that is what very important, right? So that means what they are all appearing same. Yeah, it is like a uniform, right? That's what independent of Y and Z. It is same everywhere, right? So what you can define further like this: uniform plane wave is a wave whose electric field UPW. Uniform plane wave is one whose electric field and magnetic field have constant amplitude, right? Amplitude over the equiphase surface. You see, that's what it is, independent of Y and Z. E and H are independent of Y and Z means everywhere, whatever be the location of Y and Z here, the amplitude of electric field is same, right? So that is what very important point to be noted. Then another thing is the E and H are always perpendicular to each other in uniform plane wave. That is a second point we have to remember. Fine. So what is the thing? And it is perpendicular to the direction of propagation. All are perpendicular. So we know that our wave is propagating in x direction. So Ex is 0 because they should be perpendicular to x component. So Ex 0. Similarly, Hx is also 0. This is for our uniform plane wave. Why Ex 0? Our wave is propagating in x direction. So E should not be in x. Similarly, H should not also be in x direction, right? So that's all about uniform plane wave. If you are having any doubt, please ask me in comment section. Thank you.